Let's talk about inner classes in object-oriented programming for Java. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we learned about classes, inheritance, polymorphism, and now we want to talk about inner classes. When we are defining a class, we can have other classes sitting as a child of the current class. This gives another layer of powerful options for object-oriented programming. In previous episodes, you saw that our vampire class is inheriting from human, and human is inheriting from creatures. Now, let's say that our vampires will have some extra concepts that only is related to the vampires and not any other type of the creature. And of course, we can put all of them as attributes on the same class, but sometimes we want to make them more organized because now we want to make different accessibility and approaches in our programming. For example, we can say that we have a class and we call it buffers. Now, this buffers is another class all by itself. It can have its own attributes, encapsulation, methods, everything. For example, let's say that we have a private int, or actually let's make it float and let's call it buffer multiplier. Then we are encapsulating it. So we say public float get the modifier and we return the buffer multiplier and public void set buff multiplier with a float amount. And here we say buffer multiplier equals to amount. And then we can have some functionality. For example, we can say public float calculate the buffer and it will just return something. For example, I don't know, 1.5f multiplied with the buffer multiplier, and then we are getting something out of it. For example, we say that we want the math class dot, I don't know, you say it, a tangent of this with another one that is buffer multiplier divided by 1.001f. Why not? Something crazy. And of course, a tangent will return double. So let's make it double. This is a method for whatever reason that sits inside our buffer class. And now in our main, now that we have a vampire, we can say vampire dot. However, if you look, we don't have a buffer. Now we can say vampire with the class name dot, and here, other than the Alice, calculate distance, inventory, Joe, registered player friends, we don't see that buffer. The reason is that let's make it with capital B first of all. Dot buffers. If we take a look, it says creatures, dot enemies, dot vampire, dot buffers is not public and cannot access. The reason is that we made this class, but we didn't make it public. If we want to have it as a private, of course, we can say a private. Now we have access here, buffers, buffers, and then here we say buffers equals to new buffers in both constructors, and then we get a method for that returns buffers class, and we say get buffers, and we return the internal buffers object. Now we can work with the object. So lowercase vampire get buffers, and we have access to anything public. However, again, this method is public, so why can't I access it? I can't see get buffers or set buffers because we now got access to a class. So this won't work the way we want to. Remember, classes are top level objects, and we want an instance of our object. Here we are returning buffers, and it says it can be exposed outside, means that hey, you can make it public. But here's the thing, normally you would think that vampires that get buffers is returning the buffers. So why can't I get access to the methods of the buffer? For example, if I now say buffers dot, I can see that calculate the buffer, get buffer multiplier, but I don't get it here outside of the class, although I'm getting the same thing using get buffers. And if I make it void to make it a deliberate error, and I use that, hey, it returns this, again, here I won't see those method calls and nothing will work actually. And as you see, this again is a vampires.buffers. And if I put dot, somehow IntelliSense became derpy. So I will just save, close everything, and I will open it and I will come back in a few minutes. And as you see, there is again no access to that method call. The thing is that the way we programmed our accessibility to the inner class is actually giving us a pointer in memory that is not the object itself. It's just a presentation of the type of the object inside the memory. So if we want to get our hand on an inner class, like in this case, the buffers, after having the outer class being initialized and we have an instance of it, we can say vampire dot buffers, and again, you see that it won't show up. Buffers equals to new vampire dot equals to vampire dot new space buffers. This is how we should have access. But in both cases, here and here, we see red. The reason is that it says cannot be accessed outside of the package. Okay, import the class. Did it solve anything? No. And no matter how many times I'm trying to import things, it won't work. Now you may say, what if I use the whole package there? And again, now that we know we have direct access by package, we still see this import class. But the main thing is on top. It says it's not public. Basically, what it is saying is that the packaging and addressing the package is not the problem. The problem is that this class is private by default. So we can simply say that it's public. And now you see that instead of this, we can say it's new vampire dot buffers. And now we have another problem. It says make buffers static, because although we have a class, it's not a static class. Instead, we could say if we go with lowercase v, now we can say that buffers equals vampire.getBuffers. Okay, if I hit buffers dot something, now I have access to everything. Also, if I put the dot here, now I have access to the get buffer or set buffer multiplier. Everything is accessible now, simply because now we made our buffer a public class. What is the use cases of inner classes? Sometimes, like this, we want a subclass that is related to the parent class, to the outer class. Also, we are making it public so that we can make instance of it, isn't it? No. Actually, if I want to make a new vampire.buffers, you see that I have an error because it says it's not a static. The only reason that you have a public inner class that is not static is that you will have a copy of it inside the outer class and you want to have access to that inner class instance from the parent class here. And you want to get access to it and do stuff like, I don't know, vampire.getBuffers.getBufferMultiplier, for example, for whatever reason. If you want an inner class that should define something for vampires, in this case, we had defined a type and we instantiated it as an object. But in this second example, we will make a public static class and we call this one effects. Now again, this class is a normal class, so it will have its own attributes, methods, encapsulation, everything like that. However, now we can come back inside main. So we say vampire dot effects, we call it effects, equals to new vampire.effects. And this time we don't have any problem. If I would copy it and I would paste it and make it buffers, and here I will make it buffers. This time we had a problem. It said that buffers was not static. However, now that we have static classes inside vampire, we can simply initialize them and make new objects of them and do whatever we want. This second scenario is being used to guide us that, hey, these effects are related to the vampire class. Of course, we could have a class somewhere called vampire effects. That was okay. But this way, we are guiding our programmers that, hey, if you want these effects, they are related to vampire class. So use them only related to vampires. And that is the inner static class.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.